All right, we will now come to sorry, chapter 3 of section 2, which is going to be factorization. So, what is factorization? Factorization is about product of factors, and factors could be a number or a algebraic variable or expression. So, per se, you have a larger expression given, then can you shorten it by doing this factorization technique? That is the overall goal. Irreducible factor means a factor which cannot be further factorized. So, first you have given a large expression with 781 and you reduced it to simpler ones. So, if you cannot factorize those simpler factors even further, so that's called irreducible. So the factorization methods. So now, okay, this is not numeric, so that you can do arithmetic operations to do that. So in order to factorize, what are the basic techniques you should follow to do it? So briefly, I already explained in the previous chapter, but let's just do it again for factorization. So overall goal of factorization is write each term as product of irreducible factors, look for and separate the common factors. So common factors, the more common factors you will keep them out, it would be reduced further. Combine the remaining factors in each term. So factorize means just take out something for which is common in all the expressions, so that you can reduce a larger expression to smaller irreducible factor sets. So when we do the examples, it will be more clear. Let's just move on. These identities, you need to remember whatever I was talking in previous chapter. These are going to be helpful for factorization also. Examples. So we will quickly jump on to examples because factorization is about um, just solving examples of larger algebraic expressions. So here I'm using little. So this is one of the examples. So this is the expression given in the top one. We are being asked to factorize it. Now you see here what could be factorized here. So how can we factorize this? So we can factorize this. Let's say this is ax square y plus bxy square plus cxyz, right? So here we can do is we see xy is common in all the places. We remove xy, then it reduced to ax plus by plus cz, or g, what you call in American English. So that is going to make it two irreducible factors. Xy cannot be reduced even further, and this one also cannot be reduced even further. So that's what the ultimate solve is. Second example, so we need to do factorization for this top expression, z minus 7 plus 7xy minus xyz. So here we will just see how we can reduce it. Here we cannot do much, but here we see xy is common, we took, and then we are getting here z minus 7 and here 7 minus z. So what we can do, we need to do something about it. So we just bring one minus 1 out of it, so that we can just make this term and this term together. So 7 minus z becomes z minus 7 when we took minus 1 factor out. And now we have z minus 7 here, z minus 7 here. We factorize that, and that remains 1 here minus xy. So it's interesting, it's good one. So we had 1, 2, 3, 4 terms, and then we factorized into um, two factors of two term each. Next, this is another example how to do factorization here. L plus m square minus 4lm. We expand it using identity minus 4lm, so it becomes L minus m square. It's very simple. Next one, this is a four term expression, and we need to factor it out. So what we can do, the 25 square is here, and then these ones are here. So what we see here is, can we use some identities to do it? Now, can we do? You see here, it is 2b whole square can be possible here, 7c whole square can be possible, and then 2 multiplied by 2b and 7c. So this is also 28 is here. So what we try to do, okay, let's keep it here, and then we are going to use this identity to take minus 1 um, common out of last three terms. So we can use a identity equation to replace these three terms with these two terms. 2b minus 7c whole square is this 3. So then now this is again x square minus y square form. We can use another identity to put that, and then that reduced to these two terms. We cannot, now these are kind of ultimate irreducible factors, and it cannot be reduced even further. So these four terms, which was looking complicated, could be simplified to multiplication of two three term expressions. That is all about factorization. Just reduce it to different factors. Next one is the last one, I think. Showing a simple division. So how we can do it? Y plus 5 is here, and so how to do it? Now, in order to reduce it, we need to see that whether we can have a factor of y plus 5 in the top. So let's matter of trying it. So we just split it out. 2y plus 5y equal to this 7y. We split it. Then we do y common, y plus 5, and then here we took 2 common, this 2y and 10, 2 common, y plus 5. So y plus 2 into y plus 5, and that remaining one, this cancels, y plus 5, y plus 5 is getting cancelled, and remaining one is y plus 2. Simple. Okay, little more complicated division factorization. So this is the one with problem statement given, this expression, which is doing that 4yz multiplied by z square plus 6g minus 16 by 2y multiplied by z plus 8. So we need to just reduce it. So we can see here this 4y and this 2y can be reduced to 2 here. So here just 2z remaining. And here now we worry about factorizing it further. So bottom one again, z plus 8 is there, and then how we can reduce it? Can we reduce it to a form of z plus 8 or whatsoever? We need to see whether what we can factor it out. 2z remains here, and here we can do it as right. So we need to use identities. We need to see whether we can convert it to z plus 8 whole square, and that's what we are trying to. So we are just writing out what is z plus 8 whole square look like, and then whatever available in this term, if we do z plus 8 whole square, what are the remaining ones we need to do minus with. So what is there? So this got to be z plus 8 whole square means it is going to be z square plus 64 plus 2 multiplied by 8 into z. So 2 multiplied by 8 into z is 16z. So we need to minus 10g, 10g or z, whatever you're saying. And then it was minus 16, but we need 64, so we need to minus 80, so that we can get This 2z remains as usual, but we can able to get z plus 8 whole square plus this again term what came out to be where we minus 10 came out in z plus 8. So it could be even reduced even further, so which could be z plus 8 could be taken out from down denominator and numerator z plus 8 here, and which remains out to be z plus 8 minus 10 and 2z, so 2z multiplied by z minus 2. So it was kind of grouping them in such a way that we can try to deduce it further and further, and we need to make a focus that okay, numerator is like this. Now if we need to reduce it with factorization, can we um make out a common factor between numerator and denominator so that we can cancel them out. So z plus 8 was the hint, so that we can convert it to z plus 8 whole square or some z plus 8 form, and we can cancel it out, and that's how it turned out. That's it for today. But again, this is factorization chapter number 14. You need to practice all the exercises to become expert in this. Only if you practice by looking into examples and whatever we covered here, then can only be you a expert on this topic. If needed, we can use reference books to practice further. Books like R.S. Agrawal or some other Oswald guides, whatsoever are there, you can use that to practice further. All right. Thank you.